Page 3, so we're going to start with a transformation. So first thing is we have x cubed, and we want to transform it with these different movements or compressions or stretches, whatever you want to call it. Okay, so first I'm going to do one step at a time, okay, because this one can get kind of tricky. So first of all, that's f of x, so I want to make sure that my function is not f of x, it's going to be g of x, okay. Now the first movement is 6 units left. 6 units left. Okay, so I'm going to go ahead and put that in. So remember, horizontal is inside. So I'm going to do x. Remember, x is a liar, so if I want to go left in the negative direction, I do plus 6. Then it's a reflection over the y-axis. Okay, so this is also a little tricky because that means it's inside the parentheses. Okay, and if I put a negative here, that negative is not just being placed on the x, it's being placed in everything inside. So that means I'm going to have an additional set of parentheses here. Okay? Okay, so we got that and we got that. Now this is where we need to do a little bit of thinking. Okay, so horizontal compression, okay, going this way. Remember, horizontal is affected on the inside. Okay, so then that means, I'm going to widen this out a little bit, that I need to put that number on the inside. Now compressions, remember, the number has to be greater than 1. Greater than 1. Okay, so that means not 1/4, but we're going to put 4. So we're going to put the 4 here, and don't forget that negative, because we're the reflection over the y-axis. And then I have x plus 6. Okay? And that's pretty much it, but now I want to simplify that. So now I have, just distribute the 4, that's pretty much just negative 4x minus 24. Okay? So just remember when you do this and you do the translation, or the shift, put that in there, then put that, and you get a reflection or a compression or stretch, make sure you put that outside. And you're going to have to put an additional set of parentheses there and then distribute that. Okay? All right. And if I were to give you this, okay, let's say that would look like this, then that means you would have to actually take the GCF, okay, in order to find the actual movement. This is kind of like the bonus question on your last quiz. Okay? All right, so now vertical stretch. Reciprocal function. Okay? Reciprocal just meaning you take x and flip it. So this is basically the reciprocal of, a linear function. Okay, so now a vertical stretch by a factor of 3. Remember, vertical is on the outside of the function. So remember, we're going to use, I'm going to use a new letter. Okay, since we just made a g over there, I'm going to use h of x here. Okay, so vertical stretch by 3, that's outside. And remember, if it's outside, we don't flip it. We don't do the opposite. It's not a liar. Okay, so then we have 3 times 1 over x. Then a translation 4 units left. Now with reciprocal functions, if you notice, the x is in the denominator. So that's where the inside of the function will be. So what you're going to do here, okay, is that it will be basically the parentheses are on the bottom of this function, or in the denominator. So we want to go left, and that's the negative direction. So we're going to do plus 4. Okay, like this. Okay, then a reflection over the x-axis. Remember, that's a vertical flip, going like that. Okay, so then that means our negative is going to go outside here. Okay, then the last one is 5 units up. Okay, vertical again, outside. So our final function is going to look like this. So now actually I'm going to simplify it one step further after this. Okay, so that'll be 1 over x plus 4. And then again, 5 units up, so plus 5 after. Okay, now simplify this a little further. Okay, what I can do is multiply the negative 3 times the 1. So I get negative 3 over x plus 4 plus 5. And h of x equals. Okay, and let me show you what that looks like. Okay, so here is, first let me show you what the original looks like. That is the 1 over x. Okay, then I take that 1 over x and I multiply 3. Oops, not. Okay, and then you see there's the vertical stretch. Okay, then the second thing we had was the movement to the left. So we did plus 4 on the bottom. You see how it moves left. And then the third thing we did was the reflection. So there's the negative and how it flips. And then the last one, again, it was we added 5 on the outside and that caused it to shift up. So that's what we're doing. Okay, so now we're here. Graph the function based on the given parameters. A parabolic function, so I know that's a u. Okay, it reflects over the y-axis, so I know it's going to flip. Vertical translation down, so that means we're going to go down 4 units. And a horizontal stretch by a factor of 7. In order to graph this, what I'm actually going to do is create the function first, and then I want it to be an accurate graph, so I'll make a table and get a couple points so that it's an accurate graph. Okay, so first, it's a parabolic function, so I know that's x squared. Reflection over x-axis, that's a negative on the outside. Okay, so negative x squared. Vertical translation down, so negative x squared minus 4. And the horizontal stretch of a factor of 7. So that means, remember, if you want to stretch, you're going to put it on the inside of the function. Okay, and it's by a factor of 7. If we want to stretch, that number has to be less than 1. So that's going to be 1 over 7. Okay, so now basically our function, which I'll put up here, we can call it f of x. It's going to be minus 1/7. Okay. Oh, no, I apologize. It's got to be a negative on the outside, just like this. Negative 1/7 x to the square minus 4. Okay, so I'm going to do a table real quick. And I know it looks intimidating, but the table is not as hard as you think. Okay, the first number I'm going to plug in is 0, because that just cancels this out. So if I plug in 0 here, I have minus 4. Okay, so then that's my first point here. And if I plug in, so I want to plug in a number that will cancel out that denominator. So I'm going to start with 7 and negative 7, because those both cancel out that number there. So if I plug that in, let's say I have, and you can use a calculator if you want. I'll do positive 7. Okay, minus 4. So these 7's cancel out, and that becomes negative on the outside. 1 squared. Oops, sorry, you guys can't see that. Minus 4. So now 1 squared is 1, but then times the negative is negative 1. Minus 4. Okay, that number is going to be minus 5. Okay, then the second one, the next one, that there, 1 over 7 times negative 7 squared out here. Okay, so now again those cancel out, however, now I have a negative in there. So negative 1. But negative 1 squared is still 1. And so that basically becomes minus 1, and I get the same number. Okay, so now I've got 3 points to make this like an accurate graph. So I'm going to go to 7, and then down to 5, or down 5. Okay, and then left 7, and down 5. Okay, and again, the reason I chose the 7 is because that cancels out the denominator and makes the point easier to find. Okay, and now, remember, it's going down, so that's my vertex. I'm going to make it going down this way. Okay. Not perfect, but at least you got a couple points to make it at least somewhat accurate. Now, any function, okay, so pick anything, vertical translation up, horizontal compression by a factor of 1/2. Okay, so let's do, I'll do another quadratic function. Okay, so we'll first start with going up 3 by adding 3. And again, we have a horizontal compression, so that means we're going to change the inside here. Okay, so we're going to go from this to a factor of 1/2. Okay, half factor of 1/2. Remember, compression, a is greater than 1. Okay, so we're going to put 2x squared and plus 3. Okay, so then our new function is going to be f of x. I'll use a different name actually. G of x is equal to 2. I can actually square that 2, and that becomes 4x squared plus 3. And now let's make a quick table. Okay, I always like to start with 0. 0 gives me 3. Sorry about that. Not sure what happened there. Okay, and then I'm going to plug in pretty much any number. I'm going to plug in numbers to the left and numbers to the right. Okay, so first I'm going to do 1, and then -1, 2, and then -2, and see what I get. Okay, so I plug in 1, oops, sorry, to this function here, 4x squared plus 3. I'm going to plug in here 1, so that's going to be just 4 plus 3, which is 7. -1 gives me the same thing. 2 squared is 4, times 4 is 16, plus 3, well, that's not going to work. Or it does work, but it's not going to fit on the graph. So I'm not going to be able to put these points, so I'll just stick with these. Okay, so we'll have 0 and 3. And remember, it went up, so it's up at 3. Okay, then we have 1 and 7, and -1 and 7. So there's our graph. And if you notice, it looks a lot skinnier because we compressed it horizontally. Okay, and it went up 3. Okay. Okay, now let's go down to number 10. Describe the transformation of a given function. Okay, well first, let's start out here. We got a vertical shift of up 1. Okay. Now, the outside, remember the outside here, any number outside affects anything vertically, and this is going to cause, if you notice, it's greater than 1. Okay, so that's going to cause a stretch. So vertical stretch, and by a factor of whatever this number is. So it's by a factor of 5/4. And remember, if it's inside, like a compression or stretch, it's the opposite. Okay, so now, if you notice, there's a negative on the inside. So what I actually have to do to really determine what's happening is factor out that negative on the inside. Kind of like we did in the reverse when we did number 8. Okay, we distributed the negative. Here I have to do the reverse of that. Now I have to take it out. Okay, so now this becomes negative x plus 3 squared plus 1. Okay, and that will, now I know that, first of all, inside is a reflection over the y-axis, because it's going it's rotating horizontally. Okay, then it's plus 3, so that means I'm going shift right, sorry, not right, left 3 units. Okay, so remember, again, if you see this, any number here, remember to factor it out in order to figure out what the actual shift is, left or right. Okay, okay, now over here, this is the square root function. First, let's point out the negative, and that's on the outside, so that's a reflection over x, over the x-axis. Okay, and then on the inside, okay, if you notice again, there's a number in front of the x, so we want to factor that out. So base of the GCF between those two is 2, and this becomes x minus 4. Okay, so that will tell us exactly what's going on. So first of all, that's a 2 bigger than 1, and remember the inside is horizontal. So if it's bigger than 1, it's going to cause a compression. It's going to squeeze it. Okay, and remember, by a factor of whatever the opposite of that is. So a factor of 1/2. Okay, and then now we see that it's minus 4. And remember, if it's minus, that means it's going in the plus direction. So it means it's going right 4. Okay, that is page 3.